everyone. My name is Dmitry Sumin. I'm head of products at AB Handshake. And today I would like to present our solution against smishing and impersonation fraud. Now, the problem of SMS fraud is not exactly new. What is new is the scope of the problem and the volume of the fraudulent messages which have been sent and received by operators within the recent years. At this point where we are, we see that SMS is not trusted as a valid communication method anymore by both the customers and the operators. And what's even worse, we see trends to decline of the SMS HTTP traffic because the brands are also shifting to alternative channels, thus limiting and declining the number of SMS HTTP messages sent towards the operators. One of the most dangerous and damaging type of SMS fraud is smishing and impersonation fraud. These frauds affect not only the operators, but also individuals, subscribers of mobile operators, and also business customers, enterprises, banks. The end users affected by this fraud receive messages impersonating well-known brands, containing links which fraudsters use to illegally gain access to individuals' banking, social media accounts. And also recently there has been a steady trend to use smishing links for illegal SIM swap, which then enables the fraudsters to gain access to user personal data and sensitive information. Now, what's missing on the market is obviously a solution against this type of fraud, because judging by the fact that the number of fraudulent messages is always growing, we do need to employ more advanced tactics and techniques to combat that. Typically, the countermeasures for mobile operators at the moment includes relying on their existing SMS firewalls, sometimes upgrading that with some additional tools, for example, the databases of fraudulent domains, which of course cannot be updated in real time, so they do not provide sufficient protection. Furthermore, the detection capabilities of the MNOs are currently limited by regulations that may apply to their activities and the detection capabilities of various countries, where, for example, the ability to look and analyze text can be limited by the regulator. Now, what's required, of course, is a solution that would be able to overcome these limitations. And because the problem is quite complex, the solution is also going to be quite complex, I'm afraid. And what we do propose here is a combination of actually two technologies. So one is the real-time SMS validation and end-to-end validation between two parties, and also an AI-based mechanism, an AI-based engine for analyzing and validating SMS. Our solution we do propose and we install at the operator premises or virtually as a cloud solution consists of two main technologies, of two main modules. That is the machine learning based module for the analysis of multiple parameters of the message, and also the AB Handshake validation framework, which enables the interaction between the operator and multiple originating parties, which could be enterprises, banks, or other operators. It is important to mention at this point that both modules can operate independently, and depending on each case, depending on each specific installation, we do propose a specific combination of the two, a specific setup, which would most efficiently solve the problem of the customer. Now, this is a high-level, let's say, representation of how the solutions potentially work together. We see here that while the AI module is monitoring the messages coming from all sources of interconnect towards the mobile operator, in cases where there's a direct communication between the mobile operator and the brand, the messages can undergo real-time validation, which provides an even more accurate and reliable framework to validate both the source of the message and its contents, thus protecting both the brand and the subscriber from smishing. Now let's look at these modules at a high level separately. So the first one, of course, is the AI engine, which not only analyzes multiple components, multiple layers of the message, but we do work with both traffic pattern overall. We do analyze the sender layer and also, of course, the content, including the links of the message, links contained in the message. At a closer, I would say, if we zoom in even closer, we do see that the, let's say, sub-tools and the modules which allow the AI to be efficient in smishing prevention include the database of legal services, legal domains. Also, of course, we do run semantic text analysis, and again, that functionality is available in different languages to make sure that a certain message does not resemble, let's say, if a message does not include specific trigger words, which typically are present in fraudulent communications. Of course, we do not only analyze the message parameters separately, but we also closely look at the correlation between those, and thus spotting and detecting any, let's say, inconsistency between, for example, the content and the header, the originator of the message. We involve the predictive AI models for link monitoring. So even if the link is not present in any of our databases, we still, of course, can analyze that in real time, and AI can detect whether the link is potentially harmful for the end user. And we do look at SMS patterns, of course, having implemented the solution multiple sites and monitoring the traffic to multiple destinations. We do have this capability of sometimes identifying smishing attacks even before they reach a certain customer. Now, to complement that, we do have this, let's say, second option, the SMS validation framework. Now, this comes into play where there's an opportunity to have, let's say, direct interconnection and direct communication, let's say, between the operator and the originator of the messages. In this case, that could be a bank, an enterprise, or another sender of SMS traffic. Now, what it allows to establish is via a secure end-to-end framework, it allows us to detect whether the message is delivered to the mobile operator and ultimately to the customer without any changes. So the same message that has been originated by the brand is the same message that has been received at the operator level. We can do that by verifying the sender ID, the number of messages, and of course the hash of the text between the originating and terminating points. What is good in this case is that additionally here we can avoid the regulation precautions, because we do not actually read the text even by methods of AI. We only work with the hash of the text. Additionally, this framework is very efficient in preventing impersonation fraud, because when a fraudster tries to send a message impersonating the bank, for example, in this case, and using the bank sender ID, this message would be blocked because it would not be validated by the bank. This approach we do implement, and this combination, let's say, has multiple benefits and allows us to create a really flexible and convenient solution for the operators to use. First of all, of course, both modules can be installed both in virtual machines or in a cloud, for example, or within the operator's network. And this provides us significant flexibility in terms of aligning our solution with the applicable IT security procedures, data privacy regulations, or any other norms that we need to abide. Also, of course, the customer in any case receive the access to a real-time dashboard, real-time statistics. Of course, we do provide flexible reporting, and most important of all, we do provide quite flexible configuration and alerting about the blocking, about the fraudulent messages. So why it is important? It is important because in addition to some of the regulations being limiting the operators in terms of the detection, because, for example, in some of the countries, you cannot completely analyze the text of the message. Also, there are limitations as to where and how the operators can block fraudulent messages. In this case, when, for example, the operator has the capability of detecting a fraudulent message, but does not have the capability to block that, we do provide additional functionality, for example, flagging the messages for the customers of the operator as potentially dangerous, as potentially fraudulent, thus preventing them from the potential attacks. Of course, this comprehensive approach provides multiple benefits for all the parties involved in the communication, so that the subscribers of the operator receive, say, clean traffic without fraudulent messages. There are fewer customer complaints, and all in all, the communication towards SMS messages communicated towards a certain operator are trusted as a secure route. Of course, both the business customers and the subscribers of the operators also benefit from the SMS channel becoming more secure. The negative impact on the brands which are being spoofed is reduced significantly, and ultimately, of course, subscribers receive less fraudulent messages, and there are less cases where they do lose significant sums of money due to quite intricate and cleverly designed attacks. Why why did we come up with a solution? Of course, we do have a great team behind that. So our team is highly proficient, not only with very relevant and long-standing telecom experience, but also we do have a number of experts in maths and mathematical PhDs, which are also assisting us with the configuration and further development of the AI. Our solutions are recognized by multiple industry working groups, and we do maintain a very good combination of, on the one hand, supporting all the basic industry standards and some basic telecom protocols. On the other hand, carefully observing that our solutions are patented and recognized as EB Handshake proprietary solutions. Also, of course, what we benefit from is the global visibility of our solution. We do work with over 200 million call attempts daily and billions of SMS messages annually, which gives us a good visibility globally and a good understanding of the normal traffic patterns and the ability to detect fraudulent messages on the traffic analysis layer. One crucial thing here is also not to provide the solution, let's say, as a neat concept, but also do provide something which is integrated within the operator's network. Our solution is fully adapted to that, so we can provide our solution either as a new node or integrate with the existing operator's infrastructure. For example, we can integrate with both SMS firewall or SMS C elements, which allows us, the operator, to seamlessly put our solution to the network and start benefiting from its activity from day one. The solution is currently undergoing multiple proof of concept projects, and we do, of course, and at the moment we are, of course, limited by applicable NDAs, but we do expect to share the results and the aggregate statistics of those as soon as we are through. We are also quite flexible in terms of the integration because, as I mentioned, we can integrate with and on top of existing network elements. In case where this is not possible or feasible for any reason, we are able to provide our own SMS firewall, let's say, as part of the solution to enable, again, a smooth integration with the operator's network. And of course, we do support all typically used protocols for receiving the signaling data we need for the solution to operate. Basically, from the network side, we need to receive very basic information, the sender ID, the B number, and the content of the message if permitted. So basically, quite a simple integration would be sufficient for the operator to start using the solution. In terms of our plans for the future, of course, we do see that with the further rollout of the solution, we will be able to further improve that on several, let's say, levels. First of all, of course, that's on the AI level, the access to additional data samples and access to additional traffic will further enhance the accuracy of the solution. On the other hand, with the growth of the SMS validation framework, of course, we will be able to provide this validation service to more and more operators, protecting a more significant amount of their traffic from any fraudulent manipulations. Of course, we do also see that both for us and the industry on the whole, there's also a requirement to closely work with the national telecommunication regulatory authorities to further simplify and standardize the rules around the handling of potentially fraudulent messages, of the rules regulating the capabilities for smishing and impersonation by fraud detection, and of course to authorize the operators to block these messages once sufficient evidence of message being fraudulent is obtained by the operator. So with that being said, I have come to the end of my presentation, and thank you.